Hi there, welcome back. Welcome back to the channel. Welcome to a new project. This is the first video in the restoration series for a Philips Reverbeo B7X14A. This is jumping into the big league. I did the smaller one, the B4X recently. But at the time I mentioned, I had a big brother on its way. It arrived. You can see it's been hacked already. And what I'm going to show you here is precisely from the start onwards. This radio is special because it's got incredible speakers. It's got a stereo amplification stage, so two separate amplifiers effectively using an EL84. Now, the stereo only works on external input, so radio is only mono. But if you feed an external input at the back, you can get stereo. And with the size of speakers and the detail that went into this, it should sound pretty amazing. This is a perfect candidate for one of the add-ons of the Bluetooth function, which I believe I will be doing it before the end of the project. So it should be fun. And again, it's a Philips, so we can expect a whole lot of quirks. Things are done slightly differently to what I'm used to with the German sets, but it's always fun to learn something new. The other thing it's got is a reverb tank on there. It's a Reverbeo, so it's got an actual reverb tank in there. If you don't know what that is, you take a signal, you feed it through a little transformer into two springs. At the other end, it induces a signal on another small transformer, and you've got another signal. You've got a version of that signal that you fed in comes out the other end. Then what do? Well, you feed it back into the signal path. So you create a reverb effect. I don't know what that's going to sound like on radio. I know it's very, very common in guitar amplifiers. This thing uses a very similar system. It's the springs. So it should be fun. It should be fun to see how it operates and also how they incorporate that reverb signal back into the amp. It's a feedback loop effectively, so it should be interesting as well. It's also really a hybrid unit because it's got one transistor in there. It's an OC701. It's a germanium transistor, which isn't something you commonly see on these radios, but they use that as part of the feedback circuit for the reverb signal. So again, something new. Finding something new on a radio is always something I enjoy because you learn something different. It's not always the same old, same old. Now, I'm going to do this pretty carefully. I've done some of it already. You can probably establish that I'm doing this intro at the end of this first stage. I can tell you I found some pretty strange things on here. Well, I won't tell you anymore. I'll spoil it for you. So just, if this thing interests you, stick around. It should be fun. This guy is big. 70 centimeters big. But it shows a heck of a lot of promise. I have no idea if this thing's going to work at all when I first switch it on. But it's one I'll be looking forward to for quite some time. I mentioned it when I did the other Philips. I wanted to do a Reverbeo. There are two main models of this. This is the B7X14A. There's the 43A as well, which is the one just came out after this one. But this thing is a monster, a lovely, lovely, lovely monster. Smelling of cigarette smoke, but we can get rid of that. So what do we have here? This is the bi-ampli version, which normally means it's got two amplifiers. And we'll see how that's wired up. It's also the Reverbeo, so it's supposed to have reverb in there. You've got the usual preset tone controls, hi-fi, speech, Reverbeo, stereo, and mono. What else do we have here? It's stereo for the external inputs, I presume. This would be normal radio, FM, and all the other AM bands, but the external inputs would be stereo. So we've got the usual stuff. Pickup input, long wave, medium wave, short wave, and FM. I don't know what this one's for. This would be, what is that? Oh, that's treble, yeah. and that is bass, volume, and of course the tuning. I'm still in awe. You might notice that. So what is the condition of this thing? Well, everything looks okay in the face, in the front. Nothing seems chipped or broken. A little bit of the wood has been treated badly. The sides, I think they're just discolored, but they seem to be okay. Nothing broken, which is always a good thing. There's a fair amount of raising of the, well, what is this? Like probably some sort of fiber coating on here. Very dirty, but we'll find out what it's like when I get that dirt off. So yeah, this thing's promising. This thing is promising to challenge me, which is always good. Let's look at the back. This thing was held in with some really weird screws, nothing to do with the originals, but we've got the usual stuff. Various antenna wiring configurations, depending on whether you want to use the antenna just for AM or for FM, and whether it's external. Maybe there's an internal one, I'm not sure. We've got the input for tape and pickup. We've got external speaker, which is an 800 ohm speaker. Always a little weird. I'm not sure what the internal speakers are, but I hope they're 4 or 6 ohms or so. And then we've got a voltage selector. Nothing much on here. There are a couple of things that are weird to me. There's a switch on here. I'm not sure if that's original or not. It may be, because there's another one on here. So I'm not sure what the business is with that. Maybe someone put it in. I'll find out. Let's see what it looks like inside. Oh dear. Yeah. Looks a bit messed up. That speaker is at an angle. Is that supposed to be like that? I wonder. It's not loose, so maybe it is supposed to be like that. Oh, it is. Because that one's also at an angle. Okay, that's fine. The reverb tank up here is completely loose. The little bits and pieces broken off here. Spring just hanging around, so it obviously came loose. Other than that, I can see everything there. You know, the tubes seem to be in place. The dirt doesn't scare me anymore. So this should be interesting. I'm going to get it out of the cabinet. If this is anything like the previous Philips one I did, it'll come out the front. So I'll figure out how to get it out and then show you what we're facing. First thing I discovered is that the sides come out quite easily. The glue that holds those cream-colored panels on is loose, and the speakers are indeed facing angled outwards, and there is one little dent or fault on this cone, but other than that, it's in perfect condition. This other side is even better. There's nothing wrong with that cone. It looks fantastic. Just some dirt. This should sound really amazing. I got that front bottom border out with 4 screws, and then the chassis itself is connected also to the base with 4 screws. Then I found that those switches at the back were actually connected to the speaker wire, so the speaker can be switched off, and there's one on each side. I cut those wires, took a photograph first, and it's out. Now I've got some stuff floating around here. Obviously the reverb tank or section is loose. There's a structural support to the base which is also loose, but I'm going to get this out of here and put it on my contraption. It'll fit on that for a change. The other one didn't. And I think we'll be ready to start. This is always the sort of scary bit. When you have a look at the inside, see what's what, see what's missing, see what's broken. Oh dear, I can see stuff here already. There's loose wires over here. This thing is just, it's been cut. No idea where that's coming from. Shouldn't be a problem, should be easy to trace. I've got the schematic for this and the service manual, so although it looks like an elephant, you know, one stake at a time, you can get through it. Little bits of old rubber, to be expected. Everything has got a patina of nicotine. Haven't had one of those for a while. The tubes are all in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and the magic eye, that's 10 tubes. They're all here. Filter cap, nice big one, probably needs restuffing. I don't see anything too majorly wrong here except for the reverb tank, which is completely loose on the side, which it's, oh, there's cut wires on here. Oh dear. Okay, these wires are cut. And on this side, there might as well be. One of them's cut. What's this? No. And the other one's just hanging by a thread. Something's broken off here. I'll have to see where that goes. In the meantime, I'll just leave this carefully over here. There's a little transformer. This wire is coming here, this one is cut. And of course we've got the reverb springs, which are, they're fine. This is one hell of a reverb tank. Okay, so far so good. 2 more loose wires, broken or cut off here. Don't know where that's coming from. Transformer looks to be okay. This is just hanging on there. This is probably from the reverb tank. Something fell off the top. I just store it in the box. These switches are very stuck. They're very stuck, they're very rusty. They're going to need some cleaning, but they seem to be all okay. These are the tone settings. I'm going to try the tuning. Well, the FM is turning. That's the FM tuning there. This is with the coils that are going in and out of that former. What if I put it on one of the others? Yep, that's turning too. There's the turning capacitor turning. So our dial cords are in place and both condensers or both tuning mechanisms are working. That's good. These guys are the 2 output transformers. Speaker wires coming off here. That one there, that one there. So it does have 2 transformers. They seem to be different, or are they? No, they seem to be the same. But these capacitors across here are definitely going to go. These are those notoriously bad Philips caps with a sort of tar coating on it. They always leak very badly. Those are the first ones I replace. This power transformer looks to be in perfect condition. It's a massive guy. Nice. This one will deliver quite a bit of power. And I also noticed that we've got, yeah, we do. We've got various selectors for the mains. We've got 110, 127, 145, 165, 220, and 245. That's good. I'm probably going to put it on 245. Not that I'm going to switch it on right now. This thing is just too scary for it to be a good idea. Let's turn this over and see what it looks like on the underside. You know what? That doesn't look too scary. There seems to be quite a bit of space to work here. They've got the usual story of putting a metal sheet between parts of the tube. But what have we got here? We've got the switches here. They all seem to be in place. We've got the tone controls. I haven't seen the volume control. Oh, it's over there. Okay. These are dual pots and they're turning. They're dual because they're stereo, left and right channel. Here's the other one, also turning. That here is the FM section in its metal shield. And this is what I mean by having this split. You see this here? This thing is right across the middle of a tube. The tube's got one section on the top, one section on the bottom. This metal shield, which is grounded, it seems, goes right across the middle. There's another one, shield down the middle. It becomes a little tricky to get in there, but we've got a lot of space. Contrary to what I was expecting, there's quite a bit of space here. Quite a few electrolytics. There's one here. 1, 2, 3. There's some more. There seems to be a transistor here. That's a transistor. I don't recall this thing having transistors, but I haven't studied the schematic well enough. That's interesting. It's got some of the mustard caps over here. They sometimes are good, sometimes are bad. not as bad as those black ones. So this shouldn't be too complicated. There I go again. I shouldn't say that. That's just inviting bad Joss. Okay, but ultimately there's quite a lot of space to work in here. It's not in bad condition, just need to clean some of the dust. That's what I'm going to do next. After that, I'm going to study the schematic a bit, see what the power supply circuit is like, and start working on the power supply as I usually do. You know the routine, power supply first, then the audio section, then I go back to the radio. So back to the radio as in the radio sections over here. So that's what I'll be doing next. Bit of cleaning, quite a bit of cleaning. Getting rid of the dust primarily, and then I'll start looking at it a little bit more closely. One of the first tests I do to check whether the power transformer's primary circuit is working is to actually check resistance across the primary. Now this mains cable was patched, so I cut it up and I've got a multimeter across those two, measuring the resistance. And what I do is I put it on, and when you put it on, what you should get is the resistance of the primary winding. Now it's pretty obvious what we're doing. If we look at the schematic here, we've got the primary of the transformer. This is just the mains coming in here. It goes through a switch. The both lines of the mains are cut off by the switch or switched on, whichever way you want to look at it. It then goes to the primary, and there's something called a Z1, which you assume is a fuse. Now that's the primary. Secondary has got three secondaries. We've got the main secondary over here. That would probably be 200 volts, more or less, 220. So 0 in the middle, 220, 0, 220. It's going to this rectifier tube, and that's creating a full wave rectification, which then goes through a small resistor to the first filter cap. No mystery there. The other is feeding some of the tubes, so B7, B8, and some of the lamps. And there's a third here, which seems to be, I'm not sure if this is 12 volts. This could be 12. There's a 12AX7 here, I believe. But the other one is feeding some of the other tubes, and you can see there's some sort of, what is that? That would be some sort of chokes to clean the supply going to some of the tubes. So, okay, some of the tubes are being supplied by the one secondary here and the others by this one. But the first thing you do is you measure across here. If you measure the resistance from here and you flick the switch, all you're doing is you're measuring it through the switch to there, up there, cross here, down here, cross there, cross there. That switch would be closed as well. And that's what you should get. You should get the resistance of that primary winding over there. Now, I know this is not complete because we've got a voltage selector. Now, voltage selector works by choosing where on this winding you feed in your supply. If it's a high voltage like 245, it'll be at the top end. And if it's a lower voltage, it'll be different taps down the bottom, okay? Now, what I'm getting here is not encouraging. Look at this. I've got this thing across here. This is with it off. This is with it on. And it's not encouraging at all. So I have to go one step further. And what I'm going to do is I'm going to do if we look back at this schematic, I've got to do it a little bit differently. So what I'm going to do is check the resistance from here through the switch to the other side of the switch. That's the first stage for now. And then I'm going to do the same thing from here, from this one through the switch to there. Let's see how those are. So here we go. We've got it on one side. This is my switch over here. I know the cable goes straight to the switch because I've seen it going in here and going over the top. So I'm not sure which one it is. Let's switch it on. Yeah, it's on. So coming to here, what do I get? Okay, that's fine. I'll take the other side. This is the closed position. So we've already got the switch closed. I'll try this other one. And it shouldn't be this side, it'll be that side. Okay, so power's getting to here. Now what's happening? Now we can go back to the schematic and actually make that green and that green, like that, okay? But now we've got to take it further, and what we're going to do is go from one of these points. We'll start, for example, at this one. I don't know which one it is. And I want to make sure that it's getting to the transformer. So something like that. And then we'll check the other one. So let's do that. I'm going to keep it on here. And I want to see if it gets to the transformer. I know it's going through the switch, coming out of the switch. Let's look at the top side now. So we've still got that connected to there. And we need to see where this gets to. Now, it can either go straight to the transformer, or it can go to the voltage selector. So I'll check the transformer first. Let's put the beep on. We're looking for straight continuity. I'm getting something there. So this is going through, whoa, that's noisy. This is going straight there, isn't it? No, this is going through the winding. I'm not getting 0. This must be going to the middle. I'm going to go to the middle of that selector switch and see what we get there. Yep, that's a straight connection. So it's going to the middle of the selector switch. It's coming out of there and it's going into one of the windings. So it's getting to the windings. I don't know which one at the moment. I've got it at 245, so it should be to the highest resistance. But now, the other one, that means this one's going through the selector switch. That means that this one, this other one, should be going straight to one of the legs of the transformer. It's not getting through the transformer, we know that. It's going to that one. Okay, so it's getting to the transformer, that's good. Now we'll take it from there, connect this over here, and see if we've got this going anywhere else. That's itself. No, 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 no. So the mains is getting to the transformer, but the primary is open. And when I first saw this, I kind of panicked. And then I remembered there's actually a fuse here. And I looked a bit closer and I realized this is not a fuse. This thing here is not a fuse. This thing here that's connected between that point, there's a wire going here. You can't see it, but I can. There's a wire going into something here and out of this one coming to here. And that in there, when I try to move it, it actually moves. This is one of those heat fuses. This is that Z that we see on the schematic. So what I believe we have here is if I connect this to there, which is what it should be, if that fuse was not blown, then we should get that continuity we're looking for. And if that's the case, I need to just open that up and see why it's blown, or see that it is blown, and I believe it is. So I'm going to do something here. I'm going to just take one of these things and pretend this is that fuse. This is one of those that burns out when it gets too hot. Now I'm going to take this again and look at that. That is the resistance of the primary winding, and I can check that that's working because if I switch it off, it goes off, and if I power any one of the other piano keys, it comes on. Was that the resistance I was getting? 21 ohms, 21 ohms. It looks like that switch needs a bit of cleaning as well. Okay, so now I know there's a problem with that. What is it? It's a fuse, but it's probably one of those with that special metal that melts when it heats up. The idea there is that if the transformer gets too hot, if it starts drawing too much current, that thing is inside the windings, and that will melt that. It's a solder that melts at a very low melting point. I think it's like 90 degrees or something, and that breaks the connection and saves your radio. The alternative is to put an actual fuse in there. Figure out how much power this thing is going to take and put a fuse in there. But it might be something that I can actually repair. So I'm going to take it out and see if I can repair it. But in the meantime, if we look at this schematic over here, we can actually change this a bit. We can take it from here to there. We know that the winding is fine. We haven't got the voltage selector here, but we have to stop there, but we can continue here because we know that that connection is made as well. So we've started painting our picture. We haven't fixed anything yet. Let's have a look at what we can do about that. Right, I removed the goodie there, and we can see that it's actually broken or melted. The way this works is that there's this thing here, which is connected to one point there. On the other side, we have exactly the same thing connected to the other connector, right? So provided this is in place, I'm trying to move it back in place to there, right? And the other one is in place there, and that solder is holding these two together, we've got our connection. If that solder melts, which seems to be what happened here, you can see it's sort of melted on here, these things jump apart, and they are sprung precisely for that reason. It makes perfect sense. There's a bit of tension on there. If this thing gets too hot, that solder melts, and this thing jumps away, and that one jumps away. Now, there is still a bit of that solder on here, so one could argue that I could probably just melt it in place, or I can do what Dave Tipton did on a recent restoration. He actually got some of this metal. I can't for the life of me remember what it's called now. It's on the tip of my tongue, can't remember. But anyway, what I decided to do is I decided to change this somewhat. I can fix this, there's not a problem, and in fact I may still do so. But it just goes across these 2 points. So I decided to put in a fuse holder and a fuse on here. I got hold of a PCB mounted fuse holder. It's got those 2 little pins coming out the bottom. I put a bit of thickish wire, about 1mm wire, soldered to that, and then that's bent and goes into the hole there. Same on the other side. The spacing is set by having the fuse in place when I do this. So we're good to go. This is facing back, so it's nicely accessible from the back, and you can simply pop it out. Now, what fuse did I put in here? Well, this is it says on the back of the set that this thing draws up to 100 watts when running on FM. 100 watts at 220 or 230 or 240 volts is under half an amp. So I decided to put a 500 milliamp slow blow fuse. Slow blow because I don't want excessive inrush current to blow the fuse every time you switch this on. Now, what I'm going to do is I'm going to test this. I want to see that the secondaries are fine as well. And I'm just going to use the Variac. I'm going to power this up with a Variac. I'll be bringing it up slowly, and I'll be measuring 2 voltages. One will be the output from the high voltage secondary that goes to the rectifier tube. And so I'll be measuring the input points to that tube. Nothing will be getting through the tube because the tube is out. So if there's a short, it'll be in the transformer or going to the tube. The other voltage I'll be measuring is the 6.3 volts. There's 2 secondaries that have 6.3 volts. I'll have to find out which ones they are. There's actually a drawing on the service manual showing you exactly what these pins correspond to. So it's quite nice. Now, assuming this thing doesn't have any excessive current draw, and it shouldn't because all the tubes will be out, so there'll be no filament voltage being drawn, there'll be no secondary high voltage being drawn. We should get very, very little current. Assuming that's fine, then we know at least that the power transformer section is working okay. Okay, we're ready. I've got the big brother measuring the AC voltage from the secondary to ground, so only measuring one side, and little brother here is measuring one of the 6.3 volt supplies. I'm going to switch on the Variac. I've got the dim bulb tester set to it's on limit. It's got 1 light bulb, so there's a 40 watt bulb in series there. It's very low, and I'll start turning this up. We won't see anything there for a while because this needs some voltage before the measuring circuitry starts operating, so I'll just go up. Let's go up to about 50 volts. And we're reading 64, 1.4. There's less than 10 milliamp current draw, so we can't see anything there. Let's try more. About 100 volts, about 10 milliamp current draw, and we've got 122, 2.9. Okay, it's going well. Let's try 150. Current draw still very small, and our voltage is now up to 177, 4.2. Remember, that's completely unloaded. How are we doing now? 207 4.9. All looks good so far. Just over 200. 239. 5.7. Everything looks good. I'm going to go up to 220. Remember, this thing is unloaded, so I don't want to push it too much. 6.1. Okay, I'm going to try the 230, which is what I normally have here. So it's drawing 40 milliamps. That's probably just transformer losses. Maybe some of those capacitors on the heater supply. I don't see the light bulb, the panel light here going on, so that's blown. I don't think anything else is drawing current, but we've got 266 volts. That'll be the ground. 6.3 exactly. That's just a coincidence. It'll be different because when we have this loaded, it will be slightly different. Now here I'm measuring one of the sides of the transformer. That's going to pin 1 of the rectifier tube. I'll try pin 7. 266, same thing. So this transformer is producing 266, 0, 266, exactly as it should do. Okay, that's good. That's good. I'm happy that there's no shorts on the switches, no shorts on the wiring to and from the transformer. So it looks like our transformer is working well, and the fuse held out. Mind you, it didn't draw much at all. Good. One more step completed. See any difference? Yeah, I do. This thing's cleaning up very, very well. I cleaned this backplate, I cleaned this area around here, and the reason I did that is because I removed that capacitor to restuff it. And I actually tried something different this time. I used to bend out the bottom of this cap with a screwdriver. It would actually damage the rim at the bottom, just so that I could get everything out. Well, this time I decided to learn from Dave Tipton, and I started sort of prodding it out or bending it out, but very gently, and almost like stretching the aluminium. I know that sounds weird, but you can do that. If you do it carefully enough, you start sort of stretching it out. It's sort of, can't describe it, but it comes out without breaking the rim. And I then got everything out. I fitted it with 3 new capacitors. They're Nishikons, 47 microfarads at 450 volts. This was desoldered at the bottom, taken out. It's actually an easy one to take out because it's got screws. The case is not soldered to the chassis, so it was a lot easier. And I put that all in, and I then decided to do, well, before I put it in, I started cleaning this up, and look at the result. Look at this. It's beautiful. It took quite a bit of isopropyl alcohol with a natural fiber brush. Just keep scraping away and then cleaning it off with cotton swabs. And this is the result. It looks fantastic. It's coming out well. I normally do this whenever I can. I do a section of the circuit, that section that I'm working on. In this case, it was the capacitor. I clean the surrounding area. And the reason is I don't really like cleaning. So if I do it this way, I'm doing it bits at a time. And when I get to the end, everything's clean. Most of it anyway. But the result so far is I've replaced these 3 capacitors. I've also replaced the other 10 microfarad capacitor. It's an 8 microfarad. I've replaced it with a 10 microfarad capacitor. So I've got those filter capacitors all done. And I've cleaned the socket for the EZ81, the rectifier tube. So I think we're ready to see what the result is. Now, let me put this in. I've cleaned the pins as well. Put it in here, and I'm going to power it up. Okay. Let's set this up so we can power it up and see what the result is. The EZ81 produces the rectified voltage over here, which comes to here, which goes through 120 ohm resistor to the first capacitor. So I'm going to measure that. I'll call that B1 plus. That's what I'll be measuring. Reference to ground. I'll just connect this to the chassis somewhere. And I also want to measure the heater voltage. And the easiest place to pick that up is here from the one of the dial lamps, so I'll connect that to there. And this is also to ground, but I'll connect that there anyway. So we've got the 2 multimeters ready to measure the heater voltage and the B+. This lets us see everything. I've got this thing on. I've got one lamp only, 40 watts, and I'm going to put that on. It's at 0 volts, and I'm going to start turning it up slowly. What is happening? Oh dear. I'm at 66 volts on here, and that 40 watt bulb is glowing. Glowing, glowing, glowing. Whoa. We've got a short. We have a short. Ooh, okay. Let's have a look at that. All right. I've got the meter still on the B1 plus point. I've got the supply disconnected. It's all off. Instead of volts, I'm now going to measure ohms, see what okay. We have 169 ohms at the B1 plus. Now I can figure out where the short is, see which of the B pluses is shorted. That would help. Let's do this one at a time. So B1 plus, 170 ohms. Let's get the beeper away. This is the supply itself, okay, so the tube to ground, the tube output to ground is 50 ohms. The B plus is 160 ohms. That's that 120 on there. If I go to the next B plus, it's getting higher. So I think we've got a bum tube here. Let me replace the tube and see what we can establish. I've got a working one. Let's see. Let me find it. I've replaced the EZ81, and I'm going to check the resistance to ground here again. That looks much better. I'm not sure what it's supposed to be, but it's 500K, so that sounds good enough. So what I'm going to do now is we'll do the power up test again and see what we get. We'll do everything the same as we did before. B plus, heater voltage. This thing is on. This thing's at 0. Let's take it up slowly. Heater voltage is going up slowly. We've got nothing on the B plus yet because the rectified tube still doesn't have enough oomph to start the rectifier conducting. It's sort of starting. This is still at 76. Let me take it up to 100 or thereabouts. Aha. Okay, 2.6 volts heater. This thing's going up very slowly, but it is going up, and there are no shorts. There's no glow at all on the 40 watt bulb. We've already got 80 volts on there. 100. Nice. Okay. Still climbing. Let me put it up to about 150. Okay. 238, 4.1. So we're still a way off from the full supply, but we've got 240 volts. Remember, completely unloaded, so we expect this to be quite high. That will be quite high as well, because the only heater voltage that's been, or the only heater current that's been drawn is by the rectifier tube itself. Let's take it up to 200. volts. Yeah, that's coming on nicely. I'm not sure what that's supposed to be, but now obviously at this point the power tubes would start drawing current, so it would drop the voltage quite significantly. That is still at 5.5. The capacitors are 450 volt rated, so I'm not too worried about that. Let's take it to 220. 220 on the Variac. 214 going in, because there is a little bit of a drop on the 40 watt bulb. 340 volts. I'm happy with that. I'm not going to take it much higher yet because there's still a lot of checking to do on here. Good. I believe that exercise was successful. After replacing this EZ81. One more into the bin, unfortunately. Okay, let me carry on. Well, this wouldn't be an electronics old and new video without looking at the schematic, the painted schematic. But before that, I just want to show you some of the results of the cleaning that I've done. It's actually quite gratifying. In fact, it's extremely gratifying to see a chassis become what it is becoming. When you look at what was and what is, this thing is cleaning up really beautifully. This thing has got a layer of tar from cigarette smoke, and that obviously has collected an incredible amount of dust, but it also has served to protect the chassis. There's absolutely, well, I can't see any rust, which is a blessing. So I've done some cleaning around the areas that I'm going to tackle next, and obviously that's going to be the output tubes and the output driver tube. I've also cleaned around the side of the transformer. I've cleaned the magic eye. I actually found a blown resistor on the magic eye socket, so that's been replaced as well. But if we come back to the schematic, what we've got here really is what we've seen before. It's a simple power supply where we found that the main tube was blown, and then it's got these resistor capacitor networks. And the reason this schematic looks less painted than usual is because they don't actually connect these supply lines, the B+, to the various parts of the circuit. They give it a number with an arrow, all right? So it's like a net label, and then obviously that net label carries on when it's necessary, and I'll show you that. But what we've seen here is that all these capacitors have been replaced. This one over here, this last one, has got to do with FM. When you select FM, it switches off or on. I think that's how it works. Anyway, this one is a switched supply, this B3+. They've numbered this B1 or 1, 2, 4, and 3. So we've seen that. Let's look at where they go. Now we know what to expect. 1 usually goes to the transformer, the output transformer, and indeed it does. Here's 1, +1. It goes to that transformer, the primary of the output transformer, and it then obviously gets to the anode of the EL84, just as per usual. Then there's another part of the output transformer which takes that B+ through a 1.8K resistor, which was measuring perfectly fine, and that becomes your 2, okay, your B2+. Now, this is perfectly normal, nothing unusual, but it is duplicated. It's double, okay, because this thing is stereo. It's got 2 channels. This is the right channel. If we go up here, we see the left channel. That's exactly the same. You've got your +1 going to that output transformer, to the anode, goes through a 1.8K resistor, and it goes to +2. +2 being this guy over here. So it's actually coming into +2 where it meets a 50 microfarad capacitor. Then there's another small resistor, 120 ohms, to another 50 microfarad capacitor, another section of that restuffed capacitor that I've got. And then you've got 4, and then you've got a 10K, and you've got 3. So each one of these is progressively more filtered. There's less ripple on it for the various parts of the circuit. And if we go up to the circuit, you see what I've done. I've followed all the B+ lines to make sure that they're getting there. And it's just a question of putting your multimeter probe, say, on 2, and measuring to where 2 goes, to the screen grid of the EL84, and you've got to measure 0 resistance, okay? Because there's no resistor in its path. If you do this with 3, and you connect it to 3 over there on the capacitor itself, you connect your multimeter there, and you measure the resistance to the anode of this tube, this ECC83. In fact, it's a dual triode, but if you measure it, say, to pin 1, you should get 220K resistance, and that's what we have here. And it's very, very close. These resistors so far are measuring very, very close. Same applies to pin 6 of that same tube, because it's the other triode, another 220K resistor. So everything good so far. And then you just go back in the circuit and see everywhere that you're supposed to have high voltage. And you will find it comes from one of the supplies. There is one exception. This guy over here actually comes from a switch. It's to switch in the FM. So if you go to a point where they say 1SK3, I'm not sure exactly what that was, but I found a point on the switch and I measured that that resistor was correct. I've also measured from there to the anode that that resistance is correct. The resistance of that little coil is minute, so it's negligible. This one here actually comes from supply 4, B4+, 120K to pin 8. And again, B4+, 2.2K through those two coils, which are very low resistance, to the anode of this tube. So again, those resistors are fine. Here's another one, B2+, goes up there, through there, through there, through there, through there, does a zigzag over there. And it goes to pin 6 of the ECH81. You're supposed to measure just above 2.2K, and indeed it was correct. Here's another one. 2+, V2+, 56K to pin 1. Again, correct. What's the other one? The other one is this one here, where you expect high voltage. It comes down here. It should meet at 22K. And then here it's got, it's got a switch, depending on whether you're using FM or not, or rather, FM. And that will come from, what is that, 4, B4+. So you should measure 22K on that line, and indeed we do. And again here to pin 9 of the Magic Eye. That is okay, and when I tried to measure pin 7, it was open. So this resistor I've replaced, it was completely open. Again, over here on FM, it goes to the FM block through a 10K resistor. I measured as it went into the FM block. I measured that 10K, so that's correct. So if we look at this whole thing, I think that's about everything. That is everything. What I had to pay attention to over here on the switches, some of the switch functions confused me because there were some things there that on FM, it was actually being operated by switch 3. And 3 is long wave. And then I realized there's this thing over here. There's actually a lever. When you push in FM, it pulls out part of that switch. So in fact, FM activates all these over here. You can see these switches over here. But it also activates some of those over there. So those are the sort of things you've got to try to understand before you can really get a grasp of what's happening on the radio. Now, I've said this before, I'll repeat it. The way that I do this is I check the power supply, and then I go to the audio, the amplifier stage and the preamplifier stage. Now, this thing has got everything twice. Plus, there are a few little things here that make it just a little bit more interesting. And I want to understand the circuit well, so I'm going to be studying it. If we look at this part of the circuit here, it looks identical to that part of the circuit there. And indeed it is. It's got half of the ECC83, 12AX7, half of the 12AX7. It's a preamp tube, or preamp stage. It's a preamp triode over here. But there are quite a few other things. These switches are normal. They're just tone shaping switches, part of the tone shaping. But there are a few things over here that make it quite a bit more interesting. One of them has to do with the stereo mono. The way the stereo mono works here is that as long as you've got radio, it's only mono. Everything is mono. So whatever signal is going into this section to be amplified by this tube coming out of that speaker is identical to that going to this section to be amplified by that tube coming out of that speaker. That's understood. When you select pickup input from the exterior and you choose stereo, then these things go in different directions. One of them goes to here and the other one goes to there, and then you get the amplification on different stages. But there's two things here that are slightly different. One of them is this guy over here. This is the reverb tank. And the reverb tank is interesting in that it takes a signal from the speaker out, but it only takes it from one speaker out, not from both. It takes a signal in here, it reverbs it. In other words, it sends it into one side of the tank to come out of the other side of the tank. Now that's how a reverb tank works. You feed a signal into one side, you take it out of the other side, and it's got the reverb effect because of those springs, okay? We'll be looking at that more closely when we get to that. But then that signal comes in here through that capacitor, which is just basically to allow everything except DC through. And it goes to the base of this transistor. And what this does is Well, if you look at it, it's just a transistor. It's got a supply over here, which we can see from here is between 6.8 and 7.2 volts, depending on whether you're operating FM or AM. It takes that signal and it really sort of amplifies it. That's the only way I can describe it. It's amplifying that signal and it's affecting the voltage here, because that acts as an emitter resistor on a PNP transistor, so it's a load. And we've got ground over here. So what it's doing is it's taking that signal and it's amplifying it, and it's creating an effect on this current going through this resistor here. And that effect is in harmony with the signal that's coming out of this reverb tank. If you look at it here, you see. So you've got your signal, or the current being passed through here is modulated, I guess you'd call it, by the reverb signal coming out of here, which ultimately has come back, or initially has come back from your speaker. So what happens is this, at this point here, you have got, and same here, you've got an AC component, which is the modulation effect of that reverb signal that comes through here to the base of that transistor. And what this does, if we go a bit further back, this point here is connected to the cathode of that tube. Okay, and also, if we follow down here, to the cathode of that tube. So these two cathodes are both connected together. This resistor, this 82 ohms, and this capacitor are merely the cathode resistor to cathode bias both tubes simultaneously. Okay, it's a very low resistor because you've got two tubes in parallel, effectively, or the cathodes are in parallel. So the current going through there, it's twice the current that you would expect, so you've got to have half the resistance to get the same bias voltage, all right? But it's interesting in that they are modulating it at the cathode, so they are regulating or modulating the current or the bias that's allowing the current to go through here. So besides the actual signal that you've got coming in here that modulates this current going through here, creating your audio signal coming out of the speaker, you've also got this thing here, which is effectively a negative feedback, which affects that current that's being modulated through here. So it's quite interesting how they've done this. I'll be honest with you, I've never seen reverb in a radio. This is the first one that I've worked on. I've seen it in guitar amps quite a bit, but they do it differently. They actually sum the two signals together. This one I like the way they've done it, and I'm looking forward to seeing how it works. We'll be looking at that more closely. And what I'm going to be doing is looking at this section more closely. I will be checking components, swapping out capacitors like that, checking all the components, getting a more in-depth grasp on how the switching is affecting the tone shaping that's going on here, and it's on this side and also on this side. This is obviously tone shaping because it's allowing a capacitor to either go in or not, depending on which position this switch is on and depending on which position this switch is on. So it's quite interesting the way they've done it. It's always interesting to see how they tone shape these radio circuits, because they did get very creative. I'm quite accustomed to the German versions of tone shaping. I have not seen as many of the Dutch versions on the Philips radios, so I'm looking forward to really studying this a bit better and probably coming back and boring you with it. But in the meantime, my homework is clear for me. I've got some studying to do, some replacing to do, and then some explaining to do. So what I'm going to do now is give it a break. I want to thank you for your company. I really hope you've enjoyed that. I hope you stick around with me for the other videos or the continuation of this project, so we can all learn something together, me more than most. And if you've enjoyed that, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Once again, thanks for watching. Bye for now, and stay safe.